called man boat type problems, we will see how to solve these type of questions. The concept you have to know here is, see, when a center of mass is moving, the center of mass of a body will move only for external force. Only for external force, center of mass will move. For internal forces, it won't move. So when you take a boat, this is the boat which is on water. There is a man here. This man is walking from right to left. He is moving towards left. So the system has a center of mass. What I am saying is, this line of center of mass will remain there only. Here, when the man moves towards left, boat will move towards right. This is the concept. So for internal forces, the center of mass of the system will not change. The coordinate of the center of mass will not change for the internal forces. This type of thing is called internal forces. For external force only, this center of mass will move. Now, for finding shift, there is a formula which is given as delta x is equal to m1 delta x1 m2 delta x2 divided by m1 plus m2. What is delta x1 delta x2 means? It is shift in the center of mass, and delta x is the shift in the center of mass of the system. So it is like this. Suppose the block was originally here, this m1. Now the location of the center of mass is x1. Now the block moved from this point to this point. So it is x2 now. So this x2 minus x1 is called delta x1. That is shift in the center of mass of the first body. Okay. So in the case of internal forces, delta x will be equal to 0. So we will use this concept and we will solve this type of question. In this type of question, what they ask is, they'll give you the boat mass, they'll give you the man mass, they'll give you the boat length, and they will say that this man has moved from one end to another end. What is the distance moved by the boat? Okay, so we will solve it like this. So let me take a boat. This is the boat. There is a man standing here. Okay, this is called the shoreline. This is called shoreline. So here everything will be land, here everything will be water. Shoreline basically divides land and water. It is the boundary line. So this is the initial stage. Let us say the boat mass is capital M and the man mass is small m, and the boat length is L. So finally what will happen? Let us say the center of mass of the system is somewhere here. Okay. Now in the final stage, the man moves towards left, so the boat also will slightly adjust. So let us say it is, the present diagram is like this. Okay. So let us say the movement of the boat is x. The movement of the boat is x, and right now the man is standing here. So this is the final position. So we will find out what is the distance x, how much the boat shifted. So for this we will find out what is x initial, x bar initial. What is the center of mass of the system in the initial stage? It is m1 x1 plus m2 x2 by m1 plus m2. Let us say I will take the boat mass as m1. So it is m into x1. x1 means location of center of mass of the first body. It is L plus m2, which is capital M, into, where is the center of mass of the boat? If the boat length is L, it will be L by 2 divided by m plus m. Now we will find the final center of mass. Okay, you see, where is the man standing here? From the shoreline. See, we cannot shift the reference line. Reference line has to be same only. So this man m1 x1, it will be m into x, because his center of mass will be in his within the body, and it is located at x distance from the shore. Coming to the boat, it will be capital M into x plus L by 2 divided by n plus m. Just now we have seen that delta x will be equal to 0. That means, what is delta x? Delta x is x initial minus x final, which is equal to 0. It implies x initial is equal to x final. So we will equate these two. When you equate these two, the denominator will be cancelled, and you will get ml plus ml by 2 is equal to mx plus ml by 2. I have just expanded this. So here ml by 2 is cancelled, and if you are calculating, we are calculating x. So x, if you calculate, you get ml by m plus m. So this is the formula. So the distance moved by the boat, you have to take the man mass multiplied by the length divided by the total mass of the system. So in the same example, let us say if he does not move the entire distance but a partial distance. So this formula changes in that situation. Whatever is the distance moved by the man, what is L? Whatever is the distance moved by the man. Okay. So this is how we solve the question. And sometimes they will ask you that this man is going with certain speed. What is the speed of the boat? See, in these type of questions, we have to understand that we have got the displacement here. So if you differentiate, you will get the velocity, because velocity is equal to dx by dt. Suppose I ask acceleration, you have to differentiate the velocity, dv by dt. In that situation, if you differentiate this expression, you will get velocity of the boat is equal to man mass multiplied by the man speed divided by m plus n. See students, here we have taken x in this direction, right? And we are getting positive. So it means that when the boat is moving like this, the man is when the man is moving like this, the boat will adjust in the opposite direction. Suppose the man is moving like this, the boat will move like this. Okay, so they are mutually opposite. The same formula can be applied for if there are multiple people. There are multiple people. Then also you can apply the same concept. Suppose there are two people. Then also we can apply the same concept. Okay, so let's see one question on this. So you take a boat which is 250 kg. You take a man who is 50 kg. Boat length is 10 meters. Man moved from here to here. You have to find out what is the distance moved by the boat. So the distance moved by the boat will be man mass into the length divided by 250 plus 50. It is just a minute. I think it is hanging. Yeah. So it is 50 by 300 into 10. So 56 are, it is 10 by 6 meters. You have to simplify this, 2 5s and 2 3s. Okay.